Okay, so today we're going to look at the binomial expansions and Pascal's triangle. So our learning intention is the knowledge of the link between Pascal's triangle and binomial expansions and being able to use those together. Okay, we'll be successful if we can correctly construct Pascal's triangle, if we know what is meant by the binomial and binomial expansion, and correctly use Pascal's triangle to find the solution of a binomial expansion. Okay, so let's start with Pascal's triangle. So Pascal's triangle, I'll start with this way. Basically starts at 1. Yeah, and we're basically making a triangle where we go out by 1. Okay, so if I repeat that again, and so now I'm going to basically go, what is 1 plus 1? And that makes 2. Yeah, so the sums of the two above provide you with the next number down. Okay, so we keep going out with 1. Okay, so 1 plus 2 equals 3, and 2 plus 1 equals 3. I'll go out one more time. Okay, so 1 plus 3 equals 4, and 3 plus 3 equals 6, and 3 plus 1 equals 4. Okay, so what I will do is if I, and that's basically Pascal's triangle, you can keep going. So if I was to go and do it on this side, start with 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. I'll do it to the 7th row. So this is, the first row is 0, so row 0. The second is row 1, then row 2, row 3, row 4, row 5, I'll go to row 7. Okay, so 1 plus 5 is 6, 5 plus 1, 10 is 15, 20, 15, 6 and 1. 7, 6 plus 15 is 21, that's 35, 35, 21, 7 and 1. Okay, that is Pascal's triangle. And what we can do, we can also write it, so as you can see it makes a triangle, but what we can't write it, we can kind of write it with this being the apex over here. So we can write it like this. So 1, so I went 1 down the sides. Okay, so that's that one. There'll be 0. Yeah. Actually, I lie. I want to go descending order. Yep, I want to go out this way. So 1, 1, 1. That's 1. That's 2. This is 3, 3, 1. 4, 6, 4, 1. 5, 10, 10, 5, 1, 6, 15, 20, 15, 6, 1. 1 plus 6 is 7. Oh, sorry, we've got the 7th row. Oh no, we're going to keep going. Yep. So 7, 6 plus 15 is 21. 35, 35, 21, 7, 1. So what I'm doing is basically I'm adding, I'm doing pencil, I'm adding those two and I'm providing the solution below. So adding those two, provide the solution below. And if you note, I'll come back to this, but just have a quick look at the fact that I've got x to the power 0, x to the power 1, x to the power 2, all the way to x to the power of 7 and 8. Okay, I'll come back to that. So something that's really important about Pascal's triangle is there are basically ones on the outside. So a list of ones on the outside. The row is symmetrical. Yeah. So I've got 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So it's, each row is symmetrical. And you obtain the number in between by adding the two numbers above. So okay. So it is important to understand what a binomial is. Binomial is something that has two terms. And when we're talking about binomial expansion, it's basically the result or the solution of expanding a binomial product. So for example, we want to expand 1 plus x to the power of n, where n is going to increase from 0 up till 7. So let's say 1 plus x to the power of 0. Well, the solution to that, anything to the power of 0, is just 1. Okay. If I went to 1 plus x to the power of 1, well, that's just 1 plus basically 1x. Okay. If I did 1 plus x to the power of 2, so we know how to do this quite quickly. That's the same as 1 plus x times 1 plus x, but we know how to expand that quite quickly. We know it's 1 plus 2x, or 1 times x and then double it, plus 1x squared. Okay. If I did 1 plus x to the power of 3, I'll do it on here. Okay. Well, that's the same as 1 plus x times 1 plus x all squared. Yeah. And we know that this is that solution. 1 plus 2x plus x squared. So if I expand all this out, so I get 1 times 1, 1 plus 2x plus x squared, That's multiplying that all by 1. And then we're going to multiply it by x. So we've got x plus 2x squared plus x cubed. Now let's collect like terms. We've got 1 plus 3x squared, those two, plus those two, 3x plus x cubed. So I can write that. I'll write that solution down. So I've got 1, so equals 1 plus 3x squared, 3x, I'll do it in ascending order, plus 3x squared plus 1 x cubed. So let's do 1 plus x to the power of 4, and hopefully you might be seeing the pattern. So we've got 1 plus x, and that's 1 plus x to the power of 3. So we said that was 1 plus x times 1 plus 3x plus 3x squared plus x cubed. All right, so expand that. So that's 1 multiplied by all of this. And then multiply all of this by x, so we get x plus 3x squared plus 3x cubed plus x quart. Alright, collect like terms, and then we'll do it in ascending order. So how many x's we've got? 3x plus x is 4x. X squared plus 3, we get 6x squared. Now how many x cubes? We get 4x cubes, and then we get 1 to the power x4. So if I was to write that down, I've got 1 plus 4x plus 6x squared plus 4x cube, plus 1 x to the power of 4. And note how I've been writing all my coefficients in a different pen, in blue, okay? Have a look of this 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And what that happens is that actually marries what I've written in this table. Yeah? So no x to the power of zeros, and there's none there. We get 1 plus 1x. Then we get 1 plus 2x's plus 1x squared. Then we get 1, 3x squared, 1x cubed, 1, 4x, 6x squared, 4x cubed, and 1x4. Yeah. So binomial expansion, what we're doing here, marries and has a direct link of the coefficients with Pascal's triangle. So let's do some examples. I've kept Pascal's triangle here. If I want to expand 1 plus x to the power of 7 in a quick way, all right, I remember that this is row 0. I'll do it over here. So row 0, this is row 1, row 2, row 3, row 4, row 5, row 6, row 7. Okay, it's very important to start the first row at 0, and that's because anything to the power of 0 is 1. Okay, so what I do first is I basically look at this row. I might actually highlight it. this example. I'm going to write down the coefficients. So 1, 7, 21, 35, 21, 7, and 1. Alright, what I'm then going to look at is the sign. The sign is positive, so it means that all terms will be positive. I then look at the second term, which is x, and I increase the power until I get to 7. So that's the power of 0. This is x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4, x to the power of 5, sorry. 1, 2, 3, 4. Yep. Okay, so there's an extra 35, sorry. So I'm just going to squeeze it up here, sorry. 35, and that's going to be x to the power of 4. This is x to the power of 5, x to the power of 6, and x to the power of 7. Okay. I know that they're all positives. I'm going to put in my plus signs. Okay. So, x to the power of 0, that's just 1. So 1 times 1 is 1. Okay. X to the power of 1 is just x, so that becomes 7x. This becomes x squared, so 21x squared plus 35x cubed plus 35x to the power of 4 plus 21x to the power of 5 plus 7x to the power of 6 plus x to the power of 7. Okay, so the solution of 1 plus x to the power of 7 is this. This is the solution. Okay. Let's look at this one. 1 plus 2x to the power of 5. And I'm going to, first thing is look at the fifth row. So 0, 1, 2, 3, 4, 5. I'm going to write my coefficients, and I'm going to probably write it over 2 lines. So I've got 1, I've got 5, I've got 10, put another 10 here, and then I've got 5 and 1. Okay. It's positive, so I know that it's going to be, all my terms are going to also be positive. Okay. My second term, or my second term on my binomial is 2x. And what I'm going to do is I'll write my 2x, I'm going to put it to the power of 0, the first one, 2x to the power of 1, 2x to the power of 2, 2x to the power of 3, 2x to the power of 4, 2x to the power of 5. Okay. When anything to the power of 0, it just becomes 1, so that's going to be the solution of 1. 2x to the power of 1 just becomes 2x, so 2x times 5 becomes 10x. Yep. 2x to the power of 2 becomes 4x squared. So 4 times 10 is 40x squared. This is going to become 2 to the power of 3 is 8, so 8x cubed. 8 times 10 is 80. 2 to the power of 4 becomes 16, and 16 times 5, is another 80. And then 2 to the power of 5 is 32, so that's 32x to the power of 5. Okay, so the difference between this A and B, question A and question B, is they both start with 1. The second term is just an x, but here it's just a simple x, and this is a 2x. So the idea is that you put the second term into the bracket and then raise it all to the power that you require. Okay. All right, let's look at this example. We've got 1 minus x to the power of 6. Well, it looks a bit like this, but the difference is that the sign has changed. So we still operate the same way. We still go down the 6th line. I'm going to write it out quite large over 2 lines. So we've got 1, we've got 6, we've got 15, we've got 20, 15, 6, and 1. Okay. I'm not going to do signs just yet. I'm going to get my second term, and my second term is negative x. So let's put negative x to the power of 0, negative x to the power of 1, negative x to the power of 2, to the power of 3, 4, 5, and 6. Once again, I'm not going to add in my plus or minus just yet. All right. So anything to the power of 0, even if it's negative, becomes positive. So positive 1. So 1 times 1 is just 1. And now if you think of it logically, if that was 1 minus x times 1 minus lots of stuff, 1 times 1 is just 1. Yeah, so that's why it's positive. Now, negative x to the power of 1 becomes negative. So this is going to become negative 6x. Negative x to the power of 2 is negative x times negative x, and that's going to become positive x squared. So this is going to become 15x squared. Negative x to the power of 3, so negative times a positive times a negative results into a negative. So this is going to be negative 20x to the power of 3. Negative x to the power of 4 becomes positive x to the power of 4, so that's plus 15x to the power of 4. This, as it's odd, become negative, so minus 6x to the power of 5, and then plus x to the power of 6. So when you have a negative, because of the power changes, you get this alternating minus, plus, minus, plus, minus, plus. Sorry, negative, positive, negative, positive, negative, positive. Okay. All right, so let's look at this one. 1 minus 2x to the power of 5. Okay, so that's going to be the same as what we've got up here to start with. So I'm just going to write the same coefficients. Now, instead of the term being 2x, it's going to become negative 2x. Sorry. Okay. That's going to become positive. This term is going to become negative. This term is going to become positive. It's going to become negative. That's going to become positive. And that's going to become negative. Yeah, and I basically just I've used my solution here, and we get negative, positive, negative, positive, negative. Okay. Last example on this page, we've got 1 minus 2x over 5. So to the power of 4. Okay, we've got coefficients 1, 4, 6, 4, 1. Okay, it is negative 2/5 x to the power of 0. Okay. Well, that, as we know, that becomes 1. So 1 times 1 is 1. Okay, so this, okay, so we've got to the power of 1 just becomes itself. So 4 times negative 2 over 5 becomes negative 8x over 5. Okay. If I was to square the 2, that becomes 4, but I also have to square the 5, so that's 4 over 25. So 6 times 4 is 24. So 24x squared over 25. Okay, so don't forget to square the bottom. Okay, this is going to be negative. So 4 times 2 to the power of 3 is 32x cubed, and 5 to the power of 5 cubed is 125. Okay, so that's that. And lastly, we want it to the power of 4. So this is going to be positive. So 2 to the power of 4 becomes 16x to the power of 4 over 5 to the power of 4. Okay, so do not forget to square or cube the denominator as well for those examples. Okay. All right. Some examples that you might also get is we've got this example of find the integer a and b such that 1 plus root 2 over cube is a plus b root 2. Okay. So we want row 3. So if I was just start off, we've got that's my row 0, row 1, row 2, row 3. Okay. So that's what I'm looking for. So I've got yep, I'll write my, so I've got 1, I've got 3, I've got 3 and 1. It's a positive, so they're all going to be positive terms. And now I have my second term of my binomial is square root 2. Okay. So square root 2 to the power of 0 is just 1. That's 3 plus square root 2. Okay, well square root 2 to the power of 2 is just 2. So 3 times 2 is 6. Okay, so we only got 2 to the, root 2 to the power of 3, and I want it, so that's going to be the same, really, as root 2, so the last term is going to be like root 2 squared plus root 2. If that makes sense, because so root 2 to the power of 3 is the same as root 2 squared times by root 2. And the reason why I want to keep it as root 2 is because I've got a solution as b plus root 2. That's the reason why I've done that. Okay, that's 1 plus 3 root 2 plus 6. Well, remember that's going to be just 2 times root 2. Okay, collecting like terms, we've got 1 plus 6 is 7 plus 5 root 2. So therefore, a is 7 and b is 5. Okay, let's look at our next example. We want it to the 7th row. So if I do it quickly up here, we've got 1, that's so 0, 1, 2, 3, 4, 5, 6, 6. You can also note that these, you can tell this is also the row number if you look down the second row. So here we've got 7, we've got 21, 35, 35, 21, 7 and 1. Okay. It's a little bit harder. We've got 1, we've got 7, 21, 35, 35, 21, 7 and 1. It's a negative, so they're going to alternate. So firstly, I'll just put negative 7. Okay. So we've got 1 to 0, that's just 1. That's just negative 7 root 7. Okay. Well, negative 7 squared just becomes positive 7. 21 times 7 is 100 and plus 147. Okay. So remember, so this is going to be a negative. We've got 35. We're going to times it by 7 root 7 because that's like 7 squared times 7 makes 7 cubed. Alright, so I'll just leave that there for the time being because it's going to get a little bit more complicated. Okay, well this is going to be positive. So that's going to be like 35. 7 squared times 7 squared. Well, 7 squared was 7. Yep. It's negative, so this is going to be negative. I'll just put it in here, 21. And we're basically multiplying it by 7 squared times 7 squared times square root 7. This solution is going to be positive. So it's going to be 7 times 7 squared times 7 squared times another 7 squared. And when I should say root 7 squared. Yeah, it gives us 7. And this is going to be negative, so minus root 7 to the power of 7. Which that's the same as 7 squared, 7 squared, 6 root 7. Okay, so we've got 1, 7 squared plus 147. 35 times 7 is 245 square root 7. Okay. Next term is going to be positive. 35 times 49. Next term is going to be negative. We've got 21 times 49. Then we've got a positive, 7 to the power of 4. Then we've got another negative. We've got 7 cubed. Okay. So we're collecting all our whole numbers. We've got 1 plus 147 plus 1715 plus 2401. So we get 4264. Okay, and then so we've got negative 7 minus 245 minus 1029 and 343. So if that's the case, therefore A is 4,264 and B is, well, be, in this case, because it's negative, it's the same, I'm just going to write in its positive value is 1,624, okay, in this sense. Okay. Let's look at some more examples. Looking at this, going without expanding, we want to simplify this term. Okay. All I'm really looking at this situation, I'm really looking at my constants first, my whole numbers, so my coefficients, I mean. So we got 14641. Well, that's the fourth row. Okay. So we're going to have something to the power of 4. Yeah, because it's in the fourth row. So the term is, it started off with a 1. Yeah, and every other power, so 1, 2, 3, is x minus 1. Okay, the powers are alternating, so it must be negative in between. Okay, so if that was the case, if I was to expand this out, I've got 1 minus x plus 1, all to the power of 4. So that must be 2 minus x to the power of 4. Okay. If I want to expand 1 plus 0.04 to the power of 4, that should be the same number. And we want to evaluate 1.04 to the power of 4. If you notice what 1 plus 0.04 makes 1.04. Alright, we can use the same situation. We've got the coefficients were 1, 4, 6, 4, 1. The last term 0.04. It's positive. Okay, that's just 1. 4 lots of 0.04 should be 0.016. Or 0.16. 6 lots of 0.4 squared. Um, 4 lots if we want to add them all up, so plus 0.00. Okay, and that is 1.04 to the power of 4 using binomial expansion. Yep. Okay, let's look at this one. We want it to the power of 3. Okay, so if we're looking at that 0, 1, 2, 3. So we've got 1, 3, 3, 1. Okay, it is negative 2x, negative 2x, negative 2x, negative 2 over x. Okay, that becomes 1. Okay, this just becomes itself, so that's going to be negative 6 over x. 2 squared becomes 4. 4 times 3 is 12. Do not forget to square the bottom. Okay, this becomes negative, that becomes negative 8 over x cubed. Yeah, we can also write it as 1 minus 6x negative 1 plus 12x negative 2 minus 8x negative 3. But usually we prefer to write it in that form. Okay, and that's basically it. So to recap, there's a strong link between Pascal's triangles and the coefficients of a binomial expansion. So you'll be successfully correctly construct a Pascal's triangle. That's just by going ones down the sides and adding the powers, or adding the numbers to provide the next solution. We know what a binomial is and binomial expansion is, and correctly use Pascal's triangle to find the solution of a binomial expansion. Thank you.